Today in the Tech Whiteboard series, we talk about NLP, or natural language processing, and how it impacts networking, and more specifically, AIOps. Natural language processing gives machines the ability to derive meaning from human language. NLP is a combination of linguistics and AI, specifically machine learning. Right here is where NLP lies. Let's take a look at a question you might ask Marvis, our virtual network assistant. NLP converts this question into more general meaning that our models know how to interpret to provide you with actionable insights about your network needs. Let's take a look at what's really happening here. The first step in NLP is to clean up the text and convert the words into a form the computer can understand. First stop words or unimportant information like and the are removed. The remaining text is then split into smaller units like words and phrases, a process called tokenization. Next, featurization occurs, meaning each word is transformed into a vector. Vectors numerically capture the features or information about a word in a way that the computer can understand and process. Here's an example of vectorized words. More semantically similar words fall closer together. This is a crucial concept that allows NLP to be possible. Vector representations of words can extend past 3D. Higher dimensional vectors can numerically capture more meaning about a word. While each word is represented by a vector, we need to come up with an encoded vector representation for the overall sentence. Sentence-encoded vectors are valuable because they allow information about the order of the words to be captured. Because words can have varying meanings depending on their context or position in a sentence, at this point in the process, embedding models are used. Embedding models map categorical data, such as words or sentences, into high-dimensional vectors, which capture semantic meaning about the text. Embedding models are usually pre-trained on a large amount of data outside of your own, like Wikipedia, which harnesses the power of transfer learning or leveraging prior knowledge from one domain and task into a different domain and task. An example of a pre-trained embedding model is Word2Vec, which is trained on all the word data in Wikipedia, meaning it's able to embed extra meaning about the semantics of text into vectors because it's learned from so many examples what words can mean in certain contexts. The embeddings can now be fed into a machine learning model. The machine learning model learns how to understand the meaning of unseen words by comparing the similarity between the input word vectors and the word vectors, whose meanings are known from your training data. You can make sure that your model is able to recognize certain meanings by including them in your training data set. Words that are semantically similar will be closer in multidimensional space, which is how the model learns how to predict the meaning of unseen words. The closest vector with a known meaning in the vector space is the predicted meaning. As a result of decades of troubleshooting top-tier networks at Juniper, we've created a high-level structured set of training data born from decades of in-depth networking knowledge. We take real customer questions and annotate them to create our training data set. Annotation includes flagging the tokens in the question as intents, intended actions like troubleshoot, count, list, or entities. Information about the intent like device name or time frame. The training data questions are also made into vectors and sentence-encoded vectors with information about the annotation flags. So when unseen questions are asked, our model can predict the user's desired intents and entities based on how similar the unseen vectors are to the known vectors which have been trained. The benefits of NLP are clear. Resolving network issues in minutes, not days, just by asking a single question, as opposed to poking around a network looking for clues. And the versatility of using the same interface to perform tasks such as firmware upgrades allows Marvis to become a virtual member of the IT operations team. In networking, we use NLP to allow our customers to interface with Marvis, pushing AIOps to the next level. We hope this episode helps you uncover some of the magic and mystery behind our AI native network solutions.